Hi folks, before moving on to the last function we're going to look at for this year, we need to extend our knowledge of algebra a little bit. Okay, so let's take a look at the functions that we've worked on so far. So we've taken a variable and we've operated on it. Okay, so with linear functions, you take a variable, you multiply it by a constant, maybe add another constant to get a linear function. Okay, if we take a quadratic, you're squaring the variable. Cubic, you're cubing the variable. Okay, we look at a square root function, you're taking the square root of the variable, and then finally you're taking the reciprocal of the variable. All things that we're able to do. Certainly when it comes to some values, we need help from the calculator to get an estimate. So what we want to look at now is what happens when the variable itself is in the exponent. So for example, if I take the power 2 to the x, okay, so this is different from x squared, because in x squared the exponent is constant and it's the base that's varying, whereas here the base stays constant and it's the exponent that's varying. Now this isn't a problem when x is a positive integer. So if I take if I want to find the value when x is equal to 4, that's not a problem. But what happens when x is equal to negative 2? Okay, what does it mean to take a negative exponent of a number? Okay, or what about even exponent 0? Or going to the rational numbers, what does 2 to the exponent of 2/5 mean? Okay, so your calculator can certainly calculate these things for you, but we want to try to find the meaning behind these exponents that are not positive integers. Okay, so that's what we're going to be working on now in a second. Okay, so here's the investigation sheet that you'll be working on, and for numbers 1 to 3, we're just going to be confirming properties that we should already know from grade 9, possibly grade 8. Okay, and notice here we're dealing only with exponents that are positive integers, so the ones we know how to deal with. Okay, so I want you to go through this investigation. You should be going through it fairly quickly. I want you to show whatever algebra you're using to solve these, okay, and just come up with a reminder for the 3 exponent laws. Okay, so take a few minutes to finish that off and then we'll go over it together. Okay, so just a recap here that if you take x to the 5th and x cubed, well, x to the 5th is just x multiplied by itself 5 times, and then you're multiplying x multiplied by itself 3 times. So in the end, you're multiplying x 8 times in all. Okay, so that just gives us x to the 8, and you do a few of those and you realize that there's a pattern that occurs. You notice that when you multiply 2 powers with the same base, it's just a matter of adding the exponent and keeping the base the same. Okay, so this is the multiplication rule for powers, but what's very important is that the bases have to be the same and it does not change in your final answer. It's only the exponents that get added. Okay, so if we move on to the next one here, we see that we're dividing 2 powers with the same base. Now usually when there's a rule for multiplication, it's almost always a rule for division. So let's see what happens here. And we notice that we have a factor of x in the numerator and denominator of this fraction. And when we have a factor that's common in the 2, we can simplify it because x divided by x is just equal to 1. So this is just 1 times whatever's in the numerator. Again, here we see x divided by x, again, is equal to 1. We can simplify that. And lastly, we have another one, that x divided by that x, well, that's also equal to 1. So in the end, what you're left with is just 1 in the denominator and x squared in the numerator. Obviously not necessary to write x squared over 1. You do a few of these and you realize that there's a pattern, that when you're dividing powers with the same base, you can keep the base the same, and it's just a matter of subtracting the exponents. So m minus n. Okay, that's a quotient rule for exponents, or for powers. Now similarly here, the last one is, what if we take the power of a power? So we take x to the fifth and we cube that. Well, let's remember what cubing means. It means I'm multiplying x to the fifth times x to the fifth times x to the fifth. And when I multiply, or when I write all that out, I get x to the 15. Okay, and you realize that the pattern here is that when you have the power of a power, the exponents multiply to give you the simplified final answer. So this is equal to x to the m times n. Okay? So these are our three exponent laws, and what we used were the types of exponents that we are familiar with, which is positive integer exponents. Okay, in the next few investigations that we'll look at in the next videos is I want you to look at negative exponents to start. Okay, what does it mean to take the negative exponent of a number? Okay, so just give you an idea on how you should do this. So do this before you take a look at the next video. Is I'm asking you to solve these problems in two ways. So in the first one here, I'm asking you to use arithmetic. So what are the arithmetic rules you can use to simplify this here? And you should be thinking about what I just did in one of the examples above. And then the next one, I want you to use the exponent laws that we just reviewed. And hopefully you can find some connection that'll allow you to understand what a negative exponent is. Okay, so get working on that now, please.